Okay, this is the 2-3 podcast, and this is about support force. And the gist of the support force is that the support force must equal the object's weight for the object to be at rest on an object. So, what forces act on a book lying on a table? Well, let's look at it. One force is going to be from the weight from gravity, or the weight of the book. Another force is going to have to produce a net force in the upward direction to oppose the force of gravity. So that force is what we call the support force, and it's the table that's going to supply this support force. We often call it the normal force. You're going to hear me go back and forth calling it the support force and the normal force. So in this case, the table pushes up on the book with as much force as the downward weight of the book, and in the end, this is what we call, once again, the support force. The upward support force is listed as the upward support force we're going to call positive, and the downward force we're going to call, which is weight, we're going to call negative. So when we do that, we can add them together, and in the end they're going to add to 0. And once again, we write it like this. They're in mechanical equilibrium. And the book itself is actually pushing on the atoms in the table, and these atoms then push back up on to the book. So an upward support force is always as much as the downward pull of gravity. You can see there's going to be an upward support force on the floor onto the scale, and there's also a support force from the scale onto the person's foot. So what's the net force on a bathroom scale when a 110-pound person stands on it? This one's simple. It's going to be 0. The scale is not moving. So the person's pushing down on the scale, the table is pushing, the floor is pushing back up on the scale is not going to move. Let's stand on 2 bathroom scales. This is similar to the rings. What happens when you push more weight on one side than on the other? Well, the reading on each scale, if you're standing directly over the scales, the readings are going to be half. Because you're putting half your weight on one and half on the other. But if you lean to one side or the other, one scale is going to be more than the other. But in the end, the important point is the total support force on the scales is going to equal to your weight. So for an object at rest on a horizontal surface, what does the normal support force have to be equal to? It's going to have to be equal to the object's